The following video talks about graphing trigonometric functions. We're going to learn about graphing all 6 trig functions and then performing vertical transformations on those functions. So, if we understand things about the graph of sine of x, for example, at 0 for x, sine of 0 is 0. At pi over 2, the sine of 0 is 1. At pi, the sine of pi is 0. Sine of 3 pi over 2 is -1. And at 2 pi, y is back to 0. Also at negative pi over 2, sine of negative pi over 2 is -1. So if we just graph this, we're kind of aware of what it looks like. And this is something that we learned last year as well. So we have this periodic curve that's showing up. And it would continue this way. So these are smooth, they're not pointed, and it kind of looks like that. Cosecant is the reciprocal of sine. And so what I'm going to do is I'm going to graph sine and then what I'm going to do is take the reciprocal of that graph. So if I look at the reciprocal of 1, that would be 1. The reciprocal of 0 is undefined. So when I have the reciprocal of 0, that will end up being an asymptote for me. And anytime I have a -1, that will, on my new graph of cosecant, also be -1. So for example, at pi over 2, I have 1. At -3 pi over 2 and negative pi over 2, my y value is -1. And then my y values are undefined at all of the values where the sine graph is 0. So this looks like, they're not parabolas, but they look like a bunch of parabolas, some going up, some going down, and they just repeat themselves. So the next one at 5 pi over 2 is going to look exactly like the one at pi over 2, and it will just continue to repeat itself. Cosine, we should be very aware of the graph of cosine. So it will look something like this. This is once again something that we did in Algebra 2 also. So that's our graph. And then if we are looking at secant, which is the reciprocal, we can take all of the values of cosine, and the reciprocal of 1 is 1. The reciprocal of -1 is -1. And then where cosine was 0, secant is going to be undefined. So I can plug in some values onto my graph, which if I am thinking about what the graph of cosine was, and I mimic the graph of cosine on the secant graph, then what I can find is I will have asymptotes where cosine was 0, because those will end up being undefined. Then I can graph it, and it looks like, once again, they're not parabolas, but it looks like a bunch of, that was a really bad drawing, a bunch of parabolas as we go forward here. And it would continue. These are off the graph, but it would continue to go on. Now, these things all make sense because if we remember that cosine of an angle on the unit circle is x over r, remember that secant of an angle is its reciprocal. And likewise, when sine of an angle was y over r, cosecant of an angle was r over y. So these are the reciprocal functions, and that means that the y values are going to be reciprocated. So 0 becomes undefined, and -1 becomes -1, and so on. Now for tangent, if we are looking at tangent, we can also be aware that tangent is sine over cosine. So that's another property that we can kind of remember if we're struggling. So if I'm thinking about what's happening on the unit circle, at 0, sine is 0. And at pi over 2, sine is 1, but cosine is 0, so this is going to end up being undefined. And likewise, this can continue. Now, one thing that you may notice is that if we are looking at these functions, like, for example, the function tangent, we have undefined values every pi, which is the same thing as was going on secant and cosecant. The difference is an entire period of tangent can occur in 1/2 of a unit circle instead of one full unit circle. So here's what I mean. So if we're thinking about, for example, negative pi over 4, we know that tangent is -1. At positive pi over 4, tangent is +1. Then we know that we have these values of 0 that show up here. Now, what would happen at 3 pi over 4? Tangent is once again -1. At 5 pi over 4, tangent is +1. And this would continue in every single quadrant. So what I would notice about my graph is that this is super hard to draw. And part of the reason it's hard to draw is I put these points at 1/2 when I was supposed to put them at 1. So that'll make the graphing a lot easier. But what it's going to look like is, this is very hard to draw when there's a lag on the smartboard. But what I'm seeing is this repeated curvy thing. But the repetition is every pi. So notice that it repeats each of these intervals, whereas secant and cosecant, it repeated every 2 pi. Notice that this one doesn't show up again until 2 pi later, whereas on tangent, it shows up every pi. So, for example, this point is going to show up again here, and it's going to show up again here, and so on. Now, cotangent is the reciprocal of tangent, so if we looked at these, everything that was undefined is going to become 0, and everything that was 0 is going to become undefined. So if I look at my asymptotes, they're not going to be at my pi over 2s and 3 pi over 2s and stuff. They're going to be at my whole number pi's. And then if I think about the unit circle at negative pi over 4, well, let's think about pi over 4 first, because pi over 4 is probably the easiest. Pi over 4 is going to be +1, because x and y are both positive. Then once I get to the second and fourth quadrants, I'm going to have negative pi over 4. I'm going to have -1. So at negative pi over 4, I have -1. at negative 3 pi over 4, which would be over here, I would have positive 1, and so on. And so what ends up happening, just like here, remember the reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. So what ends up happening is these points end up being in the same spot, and my cotangent graph is going to look kind of like this. And once again, this one repeats every pi. So now we're just going to practice some of them with vertical transformations. So negative cosine of x plus 2. Negative cosine. So if I think about the cosine graph, that looks something like this. Well, if I have negative cosine, that means I'm going to be at negative 1 to start, 0 at pi over 2, 1 at pi, 0 at 3 pi over 2, and negative 1 at 2 pi. So it's going to look something like this. So this gives me the vertical flip or the vertical reflection. And then the plus 2, what that's going to do is that's going to do a vertical shift for me. So if this was 0, negative 1, and 1, pi, 3 pi over 2, 2 pi, pi over 2, and 0, what's going to end up happening is all of these are going to shift up by 2. And so then my values are going to look something like this. So my lowest point will be 1 and my highest point will be 3. So I have this vertical shift up 2. So you can draw it like this. This is a very acceptable way of drawing it. In my class, what I tend to do is I just change the y values here. So I would make this 3, this 2, and this 1 to represent the vertical shift up 2. So it just kind of depends on how your teacher wants it or how you like to draw it. But I just represent this. I pretend like the axis, this axis is not y equals 0, it's y equals 2. And then that kind of does my vertical shift for me. Now this one doesn't have a vertical shift, it just has a vertical stretch. And so if I'm looking at the sine graph looks something like this. So I have 0, pi over 2 pi, 3 pi over 2, and 2 pi. And then my y values are 0, 1/2, and negative 1/2, because I don't end up having any sort of vertical shift. I just have a vertical stretch. Now, one quick thing, what if, this is not on your worksheet, but what if this was y equals 1/2 cosecant x? If it was 1/2 cosecant x, what I would do is I probably would just graph sine and then make sine a dotted line or a dotted curve, and then finish it by putting asymptotes and graphing cosecant like that. So that's probably the easiest way for me to graph cosecant or secant, is to just graph sine or graph cosine and then kind of do the reciprocals from there. And then I could erase the sine or make it a dotted curve, so then it's very clear that that's not part of my answer. But if it was the cosecant, I drew that in purple. But that's not what your problem is, so I'll erase that real quick and leave the answer for just what your problem is up.